Hello, I welcome you all in this video. We are starting a new topic in mathematics called vectors. And these vectors that we are looking at are vectors that occur in two dimensions, and we are going to understand what we mean by two dimensions. So a vector is made up of two things, okay, which gives it what we're talking about two-dimensional vectors. Okay, so a vector is a quantity that has okay, so vectors, these are quantities. They have let me use a color at least that is blue. Okay, so vectors, they have magnitude, okay, they have magnitude, and they also have direction. So vectors have both the magnitude and what? And direction. Okay, so the magnitude is just the size. Okay, so I'm not going to go very much into details in these things, since this is not physics but mathematics. Okay, so vectors are represented by a line with a direction. Okay, a good example would be something like this. Okay, so this is a good example of what? Of a vector. Okay, so you can show the direction here, or you can put it there at the far end. Okay, but the whole point is that you're trying to show direction, and then it has a given size, or what we call a magnitude. And the magnitude can be, let's say this vector here, it is PQ. Okay, so the magnitude of this vector is going to be PQ. And to show that it's a vector with direction, we usually put an arrow on top here. Okay, but sometimes if this is a vector like this, we are going to say its magnitude is like this. Okay, so we just put, when we use small letters, we just put a bar below. Okay, so this one is vector A. Okay, so you can either show vectors like this, and we're going to see a number of examples that try to represent vectors in this way. Okay, so vectors, they have what we call a fixed point. Okay, when we start talking about position of vectors. Okay, so the vector, for example, this vector here is called a position vector because it is fixed to the origin. Okay, when moving against the line of segment, the sign of the vector changes. Okay, so the vector has a magnitude and also what? Direction. Okay, and now when finding the magnitude of a vector, we need first of all to understand when you want to find the magnitude of a vector, we normally use if we wanted to find the magnitude of this vector A, we just do this. This is a vector A with a bar. So to find the magnitude of this vector, we just put this. Okay, so this will show us or tell us that this is what? Magnitude. So when you see this, you're finding the magnitude. The magnitude simply means size. Okay, the magnitude simply means what? The size. So we're trying to find the size of this vector. Okay, so let's look at addition and subtraction of vectors, and this is very, very important. Okay, addition. How do we add? Okay, how do we add and what? And subtract vectors. Okay, let's just look at how to add. So addition, we'll just stick to addition, though we also have subtraction of vectors, but addition is very much easy. Okay, so addition of vectors. How do you add vectors? So vectors, they've got a rule. When you are adding two vectors, okay, we simply connect them. We connect the head and the tail. And what do we mean? So when we have this vector here, and let's say this vector is vector A, okay, and then we have another vector here, okay, and this vector, we're going to say it's vector B. Okay, so if we were to add these two vectors, we say that vector A plus vector B. Okay, now how we represent this, it's like this. Okay, you get, so this part here, it's the tail. Okay, this part here, it's the tail, and where the arrow is the head. Okay, so a vector has got a tail and a head, so you simply connect the head to the tail of another vector. Okay, and in this case, we're simply going to say vector A. Okay, that is the vector A here. we connect, this is the head of vector A, we connect the tail of vector B to the head of vector A, okay, like this. So that is vector what? Vector B, okay. Now that we have vector B there, you close, okay. So after you've connected the head and the tail of the vectors, you now are going to join, okay. You're now going to join because the head of the vector B is this one here. You're now going to join with this. So this new vector that we have here is what we call vector A plus what? Plus B, okay. So addition is very simple. The rule is that you just need to connect, okay, the vectors, okay, head and what? And tail, okay. You just need to connect the vectors head and what? And tail. Okay, so let's look at now matrix representation of vectors. We'll come to this. Let's look at matrix representation of vectors. Okay, let's look at matrix representation of vectors. Okay, so I'm just trying to create enough room here. Okay, trying to create enough room. So we've talked about the number of things. So let's look at the matrix representation. Okay, matrix representation of the vectors. Okay, let's just put it here. Wonderful. Okay, so vectors can be represented in matrix form. Okay, this is because they have two dimensions. Okay, there is the x component of the vector and the y component of the vector, which is shown or represented by this. Okay, so when we represent vectors like this, we're representing them in the what? In the matrix what? Form. Okay, in the matrix form. We are representing these vectors in a matrix form. So let's look at now how these vectors are represented. So we have the x-axis, the x-axis is here, and the y-axis is here, and we have a point here. So to show that point, we said vectors are fixed to the origin, okay? So the origin is basically here on the xy plane. So this vector will be just shown like this, okay? That is where the head of this vector will be. So this one is going northeast, okay? And then you have another one that will come here, okay? So all these are basically our vectors. So we can simply write these vectors, okay? So this is coming from O, okay? This is coming from O, okay? This is coming from O. So this vector here, it is called the vector what? OP, okay? Vector OP. And this vector OP, you can simply write it in a matrix form by taking the x component and the y component. So when you look at this part here, okay, this part here has got a y component which is 3, and when you bring it down, it has the x component which is what? Positive 2. So you can just write it in this form. So the x is on top, so 2, it will be here, 2, okay, then 3. So that is how you can show this vector in what? In component form, okay? So you can also show for this one here. This one is OQ, okay? This one, it is OQ, okay? It is OQ. OQ, this part here, the x-axis is still 2, and the y-axis is negative 2, okay? So this is the vector, okay? So you can show the vectors, like this, okay? So here we say vectors are being represented in this form, okay? Now, what if we were told to find the vector PQ? If you were asked now to find the vector PQ, and the vector PQ now is going to be all the way from here up to here, okay? So this will be the direction, the vector what? PQ, okay? The vector PQ. Now, to find the vector PQ, is how you use now addition. So the vector PQ, you are going to notice that this vector PQ, how did we get it? It's more like you are here at P and you want to go to Q, and you are going to use this direction. So you are simply going to come to PO plus OQ. Okay. Now, remember this vector that we have here in matrix form, it is OP, but here we are having PO. Now, what do you do when you reverse a direction of a vector? When you reverse a direction of a vector, you simply introduce a minus sign, then that's when you're going to write it. So vector PO is the same as negative vector what? OP. Okay, plus OQ, this is just the correct direction because this vector is going like this. Remember the arrow for this one is going up, but as we were moving like this, that's why I've introduced a negative. But for OQ, the direction is just okay. So we're just going to write it OQ the way it is. So we're going to say negative, what is OP? Vector OP it is 2 over 3. Not over, but 2 and 3, okay? Like this. Then plus, what is OQ? OQ it is what? 2, negative 2. Okay. And then this is going to be negative 2. Multiply with everything, negative 3. Okay. Now, if you've solved matrices before, you know that when you are adding matrices, they have to be of the same order. Okay, so this is a 2 by 1, 2 by 1, and you add corresponding values. So negative 2 plus 2, what's that? Negative 2 plus 2. What do we get? Okay, negative 2 plus 2. Negative 2 plus 2, this will give us 0. Negative 3 plus 2, it's more like you have negative 3. It's just like this. So give us negative 5. Okay. This one and this one automatically that will give us 0. So this is vector what? PQ. Okay. In matrix form. So you would do the same thing if it was subtraction. If it was subtraction, you would just have to put a subtraction sign there, and then you're good to go. Okay. So this is what we were just trying to look at. Okay, so now what if you're told to find the magnitude of this vector? And here they are not going to necessarily say the magnitude, but they can just tell you that find vector PQ, then they put these, okay? So the formula for any magnitude of a vector, if you have a vector A and you want to find the magnitude, you need to use this formula, okay? X squared plus what? Y squared. That's the formula using the components. Okay, that is the formula. So for this one, we're going to say x component plus y squared, and when you do this, so PQ is so this is x and this is y, so that is going to be 0 squared plus 5 squared. Okay, now here is the tricky part. Now, what do you think you get when you square 0? Okay, you still get 0. So you're just going to have 5 squared. Okay, and here this is very simple. You're going to get what? 25. Okay, 25, and this is going to give you 5. So when we say when we do this, okay, this one we just say units. These are, so this is the magnitude. Okay, so this is the magnitude. So for the magnitude, you need the components, the x and the y component, and then you also just need to find the magnitude. Okay, the magnitude. So this is how you find the magnitude. This simple formula that we have here. Okay, so vectors are pretty much simple, very easy. Okay, in the next video we're going to look at how we can solve vectors that come in paper 2. These you expect to find them in paper 1.